Hello, math students. Welcome back to Module 3, Expressions and Equations. This is Lesson 4, and it is called Using the Identity and Inverse to Write Equivalent Expressions. Today we will revisit the identity property of 0 and 1 and the use of inverses to write equivalent expressions. Remember, equivalent expressions are just multiple ways of writing the same math sentence that doesn't have an equal sign. The question that I want you to think about during this lesson is, what happens to the expression when you multiply it by a -1? Well, we'll find out. Okay, as a review, additive identity property of 0. The additive identity property of 0 means that any number plus 0 will give you the answer of itself. However, we also need to know that there is an inverse of that, so it means that any number minus itself gives you an answer of 0. So 2 minus 2 equals 0, right? Okay, we also learned that if you have 2 minus 2, that subtraction is the same thing as adding the opposite, so 2 becomes -2, and now you have 2 plus a -2, and you still get an answer of 0, okay? So -4 minus -4, well, let's use the chips to show us to prove it. 1, 2, 3, 4 negative chips is what I have. This tells me to take away 4 negative chips. Goodbye. So what number do I have left? I have 0. Okay, so let's try it again. What if we have 4 minus -4? And we remembered the rule that subtraction is the same as adding the opposite. The opposite of -4 is 4. So now I have -4 plus 4. So again, we could use the chips because we have 4 negatives, 1, 2, 3, 4 negatives, and I'm adding 4 positives, 1, 2, 3, 4 positives, and you already remembered and know that a positive and a negative together creates 0 pairs. So again, the answer is 0, okay? So what if we have the difference of 5 and 5? So what that means is difference means we're supposed to subtract. So the difference of 5 and 5. So what is 5 minus 5? Well, 5 positives, 1, 2, 3, 4, 5, right? And I'm supposed to take away the 5 positives, so goodbye. What am I left with? 0. Well, that wasn't so hard. So now let's try it again. 5 minus 5. Remembering that subtraction is the same as adding the opposite, and so we're adding the opposite of 5 is -5. So again, I have 5 positives, 1, 2, 3, 4, 5 positives. I'm supposed to add 5 negatives, 1, 2, 3, 4, 5 negatives, and when I do that, I create 0 pairs, and so what am I left with? 0 again, okay? So now, does it work when we don't actually have number values? Does it work when we're doing that to variables? The answer is yes, because you have g of something, and then it says take away that something, and you're left with 0. And we could do it also this way, that g minus g is the same as adding a -g. So if I have g and I add -g, I'm still going to end up with 0, okay? And so, the additive identity property of 0 means that whenever you are adding the opposite to itself, you're going to get an answer of 0. Or whenever you're taking a number and subtracting it by itself, you're going to come up with an answer of 0. Okay, so the sum of a number and its inverse is equal to 0. Let me say that again. The sum of a number and its inverse, so that means the opposite of it, will equal 0. And I showed that on every single problem that we did. Okay, so now let's try the multiplicative identity property of 1. So the multiplicative identity property of 1 has the same thing. So we have 3/4 divided by 3/4. Well, we have learned that if we use the identity property of 1, that division is the same thing as multiplying by the reciprocal, but you also know how to divide fractions by fractions, because if you have the common denominator, then you just get to divide straight across. So kiddos, what is 4 divided by 4? I got 1. What is 3 divided by 3? I got 1. And what is 1 divided by 1? 1. Very good. So now let's try it the other way. So we know that 3/4 divided by 3/4 is the same as multiplying by the reciprocal. The reciprocal means that the denominator becomes the numerator becomes the denominator. So I have 4/3 because that's the reciprocal. And so now I get to multiply straight across. 3 times 4 is 12. 4 times 3 is 12. 12 divided by 12 is 1. So it works both ways. Okay, now let's try this one. We have 4 divided by 4 equals 1. Okay, let's try it the other way. 4 times the reciprocal of 4 is 1/4, right? So then we multiply straight across. 4 times 1 is 4. 1 times 4 is 4. 4 divided by 4 is 1. So it worked again. Okay, now let's try it again. Common denominators get to divide straight across. 1 divided by 1 is 1. 9 divided by 9 is 1. 1 divided by 1 is 1. Now I have 1/9, and I remember that division is the same as multiplying by the reciprocal. The reciprocal of 1/9 is 9/1. Multiply straight across. 1 times 9 is 9. 9 times 1 is 9. 9 divided by 9 is 1. Holy cow, it is working every single time. That is really cool. Okay, let's try this one. Common denominators, divide straight across. And we also have to throw in a triangle this time. So a negative divided by a negative gives me an answer of a positive. 1 divided by 1 equals 1. A negative divided by a negative gives me a positive, and 3 divided by 3 gives me 1. So 1 divided by 1 is 1. Now I remember that division is the same thing as multiplying by the reciprocal. So I have negative 1/3 times the reciprocal of this is actually negative 3/1, because remember, the numerator becomes the denominator and the denominator becomes the numerator. And now I'm multiplying, so all I have to do is multiply straight across, and I have a negative times a negative gives me a positive. So 1 times 3 equals 3, and 3 times 1 equals 3. So 3 divided by 3 is 1, and I ended up with 1 as the answer. So once again, we have proven that the multiplicative identity property of 1 means that anything that you multiply by, if it's the reciprocal, you're going to get an answer of 1 every single time. So the product of a number and its multiplicative inverse is equal to 1. The product means the answer, right, of a multiplication problem of a number, 1/9, and its multiplicative inverse, that means we take the reciprocal, it will give us an answer of 1. And it worked every single time. Look at it. The reciprocal is here, and we got 1. 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 And so that's a really cool thing to see. All right? So I'm going to give you a couple to try, and I would like you to try them by yourself. I'll help you set them up, and then you're going to try it. So it says, try these. For each problem, find the sum of the two expressions. So remember, the sum means that we're adding them. Okay, so it says the opposite of 5x minus 1 and 5x. So right here, this and word right here, that's telling you that that's the plus. And so we have to have blank plus blank, because it says for each problem find the sum, okay, that's right there, of the two expressions. Well, the first expression says the opposite of 5x minus 1. Okay, well, let's talk about that. We're going to take the opposite of everything that we have. So the opposite of 5x is negative 5x, right? And the opposite of, remember what this is, if we're subtracting, it means you're adding the opposite. So what is the opposite of negative 1? A positive 1. So we're adding 1. So that's the first one, right? So the opposite of this guy and 5x. So 5x goes right there. Okay, and now what you're supposed to do is find the sum of them. So we get to add what we have in common. So look at what we have in common. This means we have 5 negative x's. So negative x, negative x, negative x, negative x, negative x, plus 1. So we have 1 positive sitting over here. And then over here it says plus 5 positive x's. Oh, x, 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 x. Well, kiddos, what happens whenever you have a positive and a negative together? Zero pair, zero pair, zero pair, zero pair, zero pair. What am I left with? One positive. So what's our answer? If we have 0 plus 1, what is 0 plus 1? 1. That's your answer. Okay? That was kind of fun, wasn't it? Okay, so let's try another one. The reciprocal of 3 and negative 6y minus 3. Okay, so again, this and right here means plus. So we're taking something plus something. Okay, the reciprocal of 3. Well, 3, when it's a fraction, looks like this, 3 over 1. So if I'm taking the reciprocal of that, then I would have 1/3, right? And we have negative 6y minus 3. Okay, that's what we have. Okay, so this one right here, we have 1/3 plus, right? Now we have 6 negative y's. So negative y, negative y, negative y, negative y, negative y, negative y. That's what we have. And then it says we have 3 negative chips. So we have 1, 2, 3 negative chips. Okay, so now what we have to do is we have to combine what we can. This is 1/3 of a chip. Okay, so if we have 3 negative chips, and then we have 1/3 of a chip, but it's positive, what does that mean that I actually have to do? It means that I have to take my 2 negative chips, so that's 2 negatives, and then this one we're going to turn into a negative 3 over 3, right there, because we're trying to deal with this guy. So now we have a 1/3, and we're going to combine these. Remember, this is negative, so we would do 3 minus 1 is 2, and it's going to be negative 2/3 or less, right? And then we have 2. So our answer would be, oh, it's a negative, negative 2 and 2/3 for that one. Okay? And what about these guys right here? Plus 6 negative y's. So our answer on that one would look like this. And this one was 1. Sorry, that's what this one would be. Okay? So that's interesting. All right, the last one that we have to do, it says 2x and negative 2x plus 3. So again, this is a plus sign. And then we're adding those two things together. So we have 2x plus negative 2x plus 3. Okay, so let's do it again. This means we have 2 positive x's plus 2 negative x's plus 3 positive chips. 1, 2, 3, right? So we have 0 pair, 0 pair. What are we left with? 3 positives. And we got an answer of 3. Okay, so that was a little bit different, but kind of fun once we actually spread it all out and did it. All right, going back to our goal. Today we will revisit the identity properties of 0 and 1 and the use of inverses to write equivalent expressions, which we just did. What happens to an expression when you multiply it by a negative 1? Let's try it. What if I have x plus 5? And I'm going to take that expression and I'm going to multiply it by a negative 1. Well, I remember this is the coefficient, and I'm supposed to multiply it by everything inside. So if I do that, I have negative 1 times x plus negative 1 times 5. And now turn that into standard form, because this is factored form, expanded form. Now let's do standard form. What is negative 1 times x? A negative times a positive is a negative x, plus a negative times a positive is a negative, and 1 times 5 is negative 5. Okay, so our answer would be negative x plus negative 5. All right, so what happens to an expression when you multiply it by negative 1? Everything inside is its opposite. So the opposite of x is negative x. The opposite of 5 is negative 5. Okay, so let me say that again. What happens to the expression when you multiply it by a negative 1? Everything inside is its opposite. So the opposite of x is negative x. The opposite of 5 is negative 5. Okay, so that's kind of an important thing to remember. All right, kiddos, that's all I have for you in today's lesson. Talk to you soon. Bye.